Hello and welcome to this lesson about operations with decimals. The learning target of this video is adding, subtracting, multiplying, and dividing decimals. And that's what I mean by operations with decimals. These are considered to be our operations. And so we're just going to talk about how to crunch numbers when some of those numbers are decimals. Now, there are going to be three types of problems, and each type of problem is going to have sort of a different technique that goes with it. And so we're just going to talk about those briefly. For adding and subtracting, it's all about lining stuff up. So lining decimals up. That's what that boils down to. For multiplication, you have to count spaces after the decimals. And for division, this one's tricky. This one's a two-parter. Part one, get ready to do some long division. And second, it's all about the divisor. And that one's going to need to be explained a little bit more. So all about the divisor. All right, so these are the three sort of methods we'll be using for the three different types of problems that we'll encounter. You have addition, subtraction problems, multiplication problems, and division problems. So let's jump into some adding and subtracting problems. So something that we'll tend to do, and by we I mean math teachers and textbooks, to kind of confuse you, make sure you're paying attention, is to write out problems horizontally. So I might do something like this, 2.25 plus 1.40. Now when it comes to adding and subtracting, it's all about lining it up vertically. So I'm going to write that off to the side here. Line up vertically. So I'm going to rewrite my problem as 2.25 plus 1.40, making sure that my decimals form a nice straight line like that. All right, so that's the goal. We have to make sure we have that. Then it's just about doing addition. So 0 plus 5 is 5, 4 plus 2 is 6, 3, box it, walk away. All right, so let's do a couple more examples just to kind of show you again how all this comes together. So maybe we're thinking about 23.8 minus 14.1. All right, so again, what we want to do is we want to make sure we are lining it up vertically. So I will take my minus sign, put it here, 14.1, and then it's just normal subtraction as long as the decimals line up. And where the decimals line up is also where the decimal will be in my answer. And so it has to be all be very rigid and everything kind of goes in its place. So 7, and I think of this is 13, so that'd be 9. That's 1, and so that goes to 0, so we just have 9.7. Now, what I might do to really make sure you're paying attention is to then kind of skew things up a little bit, and I might do something like this. So from our third problem, let's say we have 15.6 minus, and then I'm going to go 0.28. Now, this is why we really have to pay attention and line things up. So my decimal point is right here, and I have 0 to 8. Now, that looks awkward, that feels awkward, but what we have to remember is that after these numbers is an infinite number of zeros that I can pull from. So I can keep writing zeros as much as I want going this way if I need to, if I need them for something. But I don't need them in this case, so I'm going to get rid of them. But I do need this 0 right here. And now we have a subtraction problem. So think of this as, I'm borrowing the 1 from the 6, making that a 5. So I have 10 minus 8, which is 2, 5 minus 2, which is 3, and then my decimal point still goes here, forming that nice straight line. And then we have 5 minus 0, which is 5, and then 15, and there we go. So for adding and subtracting decimals, all about lining it up. And then after that, it's just normal adding and subtracting. And so if I asked you to do 1,560 minus 28, I feel like you probably wouldn't have a problem with that. The only difference is we've put decimals in certain places. Now, let's talk about multiplication. multiplication is all about being able to count. And here we don't have to line things up. In fact, I'm going to encourage you to not line things up. So let's just say we have a problem like 3.2 times 6. Here, I prefer to write them vertically. I find it easier to work with. So I'll go 3.2 times 6. But what I want to do is count how many numbers are there after the decimal. Well, I have one number after my decimal. So I'm going to keep that in the back of my mind. All right. Now, normally I wouldn't write it down on a sheet of paper, but I'm writing it down for the sake of you seeing my thought process here. And then you just do normal multiplication. It doesn't matter. You don't need to drop down this decimal like that yet or anything like that. Just do normal multiplication. So 6 times 2 is 2. And then 6 times 3 is 18, but carry that 1. We'll get a 9. Now, what we'll do is bring in this 1. We go to the far right of the number, and we're going to move it over one spot. So our final answer is 19.2. Now, let's take a quick look at a different variation of this problem. Let's go with 0.32 times 0.6. Again, you can just rewrite it. And so actually, I'll completely rewrite it. So 0.32 times 0.6. Now, it is going to be a normal multiplication. 6 times 2 is still 2. Carry the 1, we'll have 18, but that's 19. And then we'll just have a bunch of zeros here when I multiply the zeros out. Don't need to write all that out. I still have the same digits when I do the multiplication, but now I have to count how many spots were there after the decimal. 1, 2, 3. So you have to look at both numbers. So I had 3 spots. So that means I'm going to start at the far right, and I'm going to bump over 1, 2, 3 spots to the left. And so you can see we have the same numbers, 3, 2, 6, 3, 2, 6. But where the decimal goes has a huge impact on the value of the number. Because in this one, it's 0.192 instead of 19.2. And so it's all about being able to count how many decimals. Besides that, normal multiplication. Now, let's talk about the really hard one, division. So for this one, I want to start off with something that we probably know and are familiar with. So 3 times 5 is 15. I'm going to borrow these numbers. And so what I'm going to do, though, is I'm going to go with 1.5 divided by 0.3. So that's going to be our first example here. Now, one thing that I'm going to suggest that you have to do is rewrite this as a long division problem. And so the way that works, and I think some people tend to forget actually how to write stuff in long division because you get so used to kind of doing it this way that or always being presented in this, being presented like that in long division, you forget how to actually do it. There we go. All right, my pen's now picked up. All right, this is going to go here. So 1.5 goes there. Here, I'm going to put my 0.3. I'll erase this so we can do our work and stuff like that. Now, going back a couple of pages, I said for division, it's all about the divisor. The divisor is the number that's doing the dividing. In this case, it's 0.3. The rule is you have to make the divisor a whole number. Divisor a whole number. Okay, so in order to do that, I have to bump my decimal point over one spot to the right. And so whatever I do to the divisor, I'm going to do inside the division bar and bump it over one spot to the right as well. Now, this is where my decimal is going to be in my answer. So, and after that, I just treat it like normal division. 3 into 15, hey, it's 5. That was easy enough. Now, let's look at something a little more complicated. So for this one, let's go with 3.72 divided by 2.4. All right, so the process, I'm going to rewrite this in long division. 3.72 is going to go underneath my division sign, and then 2.4 goes outside of it. The divisor, again, is the one that's in the control, so I need to bump this over one spot. I'll bump this over one spot as well, and my decimal is going to be right there. And now, what I'm really doing is, whoops, not the square root, slow down there, another class. All right, 37.2 is being divided by 24. That's essentially the problem I'm doing at this point in time. All right, and so I got to ask myself, how many times does 24 go into 37? It goes in once, 24, and then I'll get 13. Bring down my 2. How many times does that go in there? I'm going to go with, I'm going to put 5, see what happens. That's 120. Oops. So, let's see here. And so now, how many times does 24 go? Oh, so wait, no, that's, oh, and then perfect, that's 5 again. And so 120 and 0, we are done. So a couple things we can take from this. One, this technique, I mean, that's key right there. Second, you got to keep going until you get a 0 down here. One thing I did a bad job of is realizing, all right, I need more numbers to finish this decimal. So like I said, there's an infinite number of these zeros out here that we can pull from if we need to. We only need to add one extra 0, and that's right here, so I could go one more step and finish off this decimal with a 5. And so our final answer there is 1.55. So to kind of recap everything, we have two camps. We have addition and subtraction, and then we have and multiplication. They're all kind of grouped together. So this is one group, this is another group, and this is pretty much normal. But there's, like, with an extra rule. So the extra rule for addition and subtraction is to line things up. For multiplication, it's all about counting. And then on the other side, we have division, which has that special rule, which is the divisor must be a whole number. Outside of that, that's it. So good luck with your work, and let me know if you have any questions.